On this question, we want to solve the exponential equation 3.32 to the x equals square root of 11 to the 1 minus 2x power. Before we start solving this equation, let's take a look at the methods that we typically use. The first method is relating the bases, and that requires us to get the same base on both sides of the equation. With the example that we're working with, we have a base of 3.32 and a base of square root of 11. If we were to put square root of 11 in our calculator, you would get approximately 3.32. And so their bases are almost the same, but since they're not exactly the same, we're not able to use this method of relating the bases. We have to rely on one of our other two methods for solving this exponential equation. Now, to solve this, we can convert to a logarithmic equation, or we can take the log of both sides. I typically prefer to take the log of both sides, so that's the method I'm going to use. So in this example, I'm going to start by taking the log, the natural log on the left, and the natural log on the right, so that we can keep our equation balanced. And once you introduce the logs, you're now allowed to use the power rule for logarithms. And the power rule for logarithms allows you to take the power and make it the coefficient on the logarithm. That would make this x natural log of 3.32 equals 1 minus 2x natural log square root of 11. The next thing I'm going to do is use the distributive property and distribute this natural log square root of 11 to each term in the parentheses. I'll have x natural log of 3.32 equals natural log square root of 11 minus 2x natural log square root of 11. Now I'm noticing that I have a term with x on the left and a term with x on the right. I want to collect the terms that have x onto one side of the equation, so I'll move this one to the left so the x's will be together. And I do have one term that doesn't have x in it, and I want that term isolated on one side of the equation. I'll leave that term on the right-hand side. So as I rearrange these terms, I would get x natural log of 3.32, and I'm going to add, since this term started off negative, when you move it to the other side of the equal sign, it becomes positive, 2x natural log square root of 11. And the natural log square root of 11 is going to stay put on the right. So I've collected the terms with x onto one side of the equation, and now I can factor out the common x. If I factor it out, I'll have x times natural log of 3.32 plus 2 natural log square root of 11 equals natural log square root of 11. Now I'm able to get x by itself. This parenthesis is being multiplied by x. I'll divide by natural log of 3.32 plus 2 natural log square root of 11. We're going to do the same thing on both sides of the equation to stay balanced. And on the left, these parentheses cancel each other out. And we're left with x equals natural log square root of 11 over natural log of 3.32 plus 2 natural log square root of 11. Now there may be some times when you would need to find an approximation for this. I'm going to get my calculator and show you how to type that expression into the calculator. So we would type natural log square root of 11, close parentheses, divided by, we need parentheses around our whole denominator because we have more than one term, natural log of 3.32, close parentheses, plus 2 natural log square root of 11. Sorry, I kind of lost my place there, so let me get back to the end. We need square root of 11. And I need to close parentheses for the log and close parenthesis for the denominator. And we get approximation of 0.333 for this expression. I arbitrarily chose to round to 3 decimal places. Make sure you pay attention to the directions in your problem. Thank you for checking out my videos. Have a great day.